Yeah, now that we know the syntax of memory statement, that it's data type and name, we have seen some data types, though we haven't gone to the subcategories in each. But before that, we would like to have a look at this name. What is this name? Name is built through an identifier, right? It's considered as an identifier. What's identifier? These are words created by the programmer. Their meaning can be changed by the programmer from time to time. So let's see how to build these identifiers. There are certain rules. Only when we frame an identifier this way, the translator recognizes it. Otherwise, the translator can't recognize it. It finds it as an illegal token. So what are these rules? First one, length of that name should be at least one character to a maximum of 256 characters. And then it can contain characters from A to Z, uppercase and lowercase, digits from 0 to 9. No special character is allowed. And in most of the languages, the only special character allowed is underscore. And it should not start with a digit. It can't start with a digit. Fine. And it cannot be a keyword. When we create a word this way, a token this way, by following these 5, then generally it becomes a legal identifier. But one good point to be noted is names must be relevant to their usage. They're identifiers. They should identify something which makes sense, isn't it? Never use names like A, B, C, X, Y, Z. These names, they don't convey a proper meaning. So always identifiers must be named with the context for which they are built for. They should have a relevant usage meaning. Yeah. So let's see some of the examples of legal and illegal identifiers. Yeah, can you check them? Now, as an example, I have welcome underscore message. Is it a valid or an invalid identifier? Similarly, hello. Similarly, hello 9. Hello underscore 9. Underscore 9, hello. First underscore name. Fine. These are some examples. I have another example. 9, hello. Hash, hello. First space name. Fine. So the first set of identifiers are valid, whereas the second set is an invalid set of identifiers, because in the second set, first one starts with a number, digit. It's illegal. The other one consists of hash. Hash is not allowed anywhere. First namespace, name is also a character and it's not allowed. We can't separate them. If at all there are 2 words and we want to connect them, then we use underscore to connect them. That's mostly why do we use that underscore. But spaces are not allowed in the names. So just some common examples of legal and illegal identifiers. Yeah, valid and invalid identifiers to give you an idea how to frame words. Another thing about these identifiers is in some languages, they are either case sensitive, yeah, and in some languages, they are case insensitive. Languages like C, they are case sensitive. Uppercase, lowercase are treated as 2 separate names altogether. Whereas when it comes to languages like Apex and all, fine, here, whether you use uppercase, lowercase, name is name. It doesn't get distinguished with the cases. Whereas in some languages, it is through cases. So make a note of this whenever you're working with the languages. Yeah, fine. So this was about identifiers. Now we know the data types and now we know the identifiers. Using these, let us try to frame memory statements in our next video. Thank you. Yep. Now, yeah, welcome back. Now we understood how to write a memory statement with the syntax data type name. But what happens when we write a memory statement within the system? Let's see. Example, fine, a memory space is allocated. How does it work? Example, string GF name. String is a data type. GF name is an identifier. We put together these two, then it becomes a memory statement. Now, what does system do with this instruction? We have defined a statement. Statement becomes an instruction for the system. On receiving instruction, system starts working. So what does it do? Memory space is allocated. Fine. So you see that green strip, that's like a memory space, and it's identified with the name that which we give. This memory space is identified by the name what we give. That's the reason why it's called identifier. It identifies something. So it's a name. It identifies the memory space. Next, another example, Boolean availability. Then a memory space is created. Yeah, and it's marked with the name availability. Now, this memory space is capable of storing relevant values. GF name can store string type value. Availability can store Boolean type value. Fine. So now let's move ahead and look into our Excel sheet and try to understand, how to write memory statements in different languages and what are the data types available. But before doing that, how exactly do I know, like I've started learning a programming language? Yeah, under normal circumstances, people feel, okay, now I've started writing so-and-so programs. Exercise 1 has been completed. Exercise 2 has been completed. So now I'm actually learning the language. No, never consider your progress that way. Yeah, there's a yardstick how you measure your progress. If you understand a token in the same way how the system understands, then you're actually becoming a programmer. This is very, very critical, very, very crucial. If you get this understanding, you don't have to learn each language separately. You can learn any language and switch from any language to any language. So that's the key, what's needed here. Fine. So make sure you always think like a translator. Translator understands each token and starts working. So we need to understand a token in the same way how the translator understands it. Fine. So in our next video, we shall have a look at our Excel sheet with respect to the data types in different languages and memory statement across multiple languages, keeping in view our core syntax data type name. Fine. See you in the next session. Thank you.